program synthesis at this moment, and the repercussions of what that might mean for the future software today. So I'll start this presentation off with a question for us here in the room. Is it possible for a computer program to write its own programs? And then as I move on, of course, it seems kind of silly saying that now, because I think everyone would probably say, of course it can. So just to give you an introduction of who I am, my name is Kory Becker. I'm a software engineer. I'm a web application developer, so for a variety of programming languages. I also have backgrounds in artificial intelligence and data science. I do research in two key areas. One of them is in genetic algorithms with evolutionary computation, where I designed a system for self-programming AI that creates programs. This was before everything was happened. So I published a research paper on it last year, I believe it was. And the research that I do is evolutionary computation to for an AI to create programs at the instruction level of a program. So to actually take the instructions in a programming language, assemble them together into programs to solve a particular target, right? Whereas what we're seeing today are large language models that will be different and get into that. I also do research on quantum computing, secondary research, and I'll talk about that in this brief. I'm also the author of the book Building Police-Enabled Apps with Alexa. That was my first published book in 2017. And by Bleeding Edge Press, this goes on to the history of, well, it tells you how to make software for the Amazon Echo. Everyone's familiar with the Echo device, Amazon. So, yes, the book is all about how to create software for the Amazon Echo. And the first chapter goes into the history of conversation chatbots, which is really interesting and very relevant to today. I talk about one of the first chatbots, Eliza. Is everyone heard of Eliza the chatbot? Yeah, developed in the 1960s. The first examples were it was developed as a psychoanalyst, very simple chatbot, very powerful, and people thought that they were actually talking to a real being on the other side of that computer screen. But it was just a computer program. And flash forward, I don't know, 60, 70 years or something like that to today. What are people doing with ChatGPT and they think they're talking to a real thing and just a computer? But it is a little bit about the psychological repercussions of that. It's a little different today than it was then. There's lots of that. So anyway, my book is on Amazon. It's rated 4 stars, so that's pretty cool. I'm also an IBM certified quantum computing developer. I'm a certification certificate of the Source Quantum Computing Library. I got that in 2021. I have a research paper archive on quantum computing for 12. I read articles on quantum computing. I'm on medium.com. Yep, read my articles, tutorials on quantum computing. I love quantum computing almost as much as AI. I'm also a member of the ITPC Quantum Technology Committee, where we facilitate quantum computing meetings and conferences and educational opportunities, as well as putting together literature and books and material like that dealing with quantum computing, trying to evangelize. With that, let's see. I guess we'll move on to a discussion of program synthesis. Yes, and with my background, I've always been fascinated by artificial intelligence. I'm going all the way back to when I was in school, and specifically, I've always been fascinated by the idea of computer program and write its own computer programs. This is my passion. This is what got me into computers. I always thought, just imagine, and it's so long ago, just imagine the capabilities a computer could do, or for the human race, if it could write its own programs. So this is what got me involved in this all the way back then, all the way through today. And that's what's so remarkable. Now, the computer programs that can create their own programs is called program synthesis. So program synthesis is all about designing design software that creates the software. Now, this can be done in a variety of different ways, but the idea of program synthesis is considered for the longest time, it's considered the holy grail of computer science. In the very early beginnings of artificial intelligence, people said, just imagine we could do this if we could harness this technology. Just think about what we could do. And so there's different ways to do program synthesis. One of them is genetic algorithms using evolutionary computation, which I just mentioned, and I'll show an example of that today, using abstract syntax trees and also a custom program language. You can also use programming by example. That's a technique that's popular by Microsoft Excel, functional. That's by someone Golani. We'll take a look at that. We'll also talk about GitHub Copilot is one of the newest ones in the cloud. And of course, ChatGPT, which is the large language models. We'll look at that as well. So let's start with genetic algorithms to see how we got to where we are today with ChatGPT by looking at some other ways. So with an evolutionary algorithm to create its own program, the way we do this is genetic algorithms simulate evolution digitally in order to create programs that get better and better to suit target goal. So the way we do this is to create a gene. A genome consists of an array of genes. Each gene is an instruction. That instruction can be very different things. You execute the genome as a program and see how close it comes to satisfying the goal. So imagine that we want to have a computer program create a mathematical expression that evaluates to a certain number, say 10. Okay? We want the computer to create a mathematical expression that evaluates values. So we can do that with the abstract syntax tree. Now, we're used to doing that in infix notation. So if you're familiar with notation, there's prefix, infix, and postfix. Infix is 5 plus 2, right? We're going to be doing prefix notation because it's easier to process using a stack and reading from the right side. And so we can form an expression. So we can start with a random selection of operators and operands in order to construct a genome. Now the computer genetic algorithm is going to create 100 or 1,000. Some of them will be closer, some of them will be worse to get into the value 10. The ones that are closer to calculating the value 10 evolve to produce children. They get better and better to both sides. So here's an example of an abstract syntax tree. In prefix expression, we have one slide. X minus plus 1 to 1. 3 from the right, stack. Whenever you get a value, push it. Whenever you get the operand, you pop 2 values. And you so you can see this tree looks like 5, 2 at the top, followed by a plus operator. That is 7. Then minus operator. Number 1, it's 7 minus 1, that's a 6. That's pretty close to the target of 10, but not quite. So with a genetic algorithm, you need a fitness method. A fitness method is what guides genetic algorithms, what programs have topics. So the way to describe mathematical expressions is to target value and subtract the difference of what the program actually calculated. So the example we just saw, the program calculated the x, right? Now this one particular program out of 100 measures. So what would be the fitness score for that? Well, we would take target value 10 minus difference. The difference is the absolute value of 10, 6. 10 minus 6 is 4. The absolute value is 4. 10 minus 4 is 6. So the fitness for this particular abstract syntax tree is 6. Now that makes sense. That's pretty simple, right? The value of calculated is 6. The fitness is 6. But if the value of calculated is 25, right, that's much worse. That's much worse than 6. If you plug that into this formula, you'll end up with negative 5. So, negative 5, of course, for a fitness score is pretty low. So out of those 2 programs, which one is going to be ranked higher? The first one, the fitness score is 6. And that's how we calculate fitness. So here's some examples of this particular system one. And by the way, my sense for all of these things. So it's not very obvious. If you're looking at a small or my name. This is I wrote this in the JS. This is to generate that expressions. See here now, here's the generate expression evaluate and came up with formula plus times 46. So that is prefix notation, and if you execute that expression, it will true right there. So that's a pretty simple example. And it completed that in just 2 generations. So that took about 2 seconds, maybe 1 second to create that. Here's another example. Create a mathematical expression by 1, 2, 3, 4, 5, 6. That's that. It came up with that's a pretty complicated one. That's a very long expression. You probably can't calculate that out. I certainly can't calculate that out. Let's have a really big stack. And that's pretty common. But it does come through. It actually does evaluate to 1, 2, 3, 4, 5, 6. You can write that down and calculate it out on pencil and paper if you want. That took about, that was only what, 402 generations? I would say this was calculated in about 10 seconds. So you can also do variables. Here's an example of a race back to the third power. So to do something like this, just train 5 examples of different types. So 1, 3, 5, 6. And it generates programs until it variables to satisfy all the test cases. So here we come with the best genome times x. Presentation. That's pretty good. That's the optimal. That's the optimal expression. That's the optimal expression for this particular part. So that also took about 10 seconds to make. It's very fast. Now, what about, is it always that good? No. So here's an example of also reasons. This is the same the other one. Does the right thing, comes up with this result. With that prefix expression, a lot more. Does that mean it doesn't work? No, it doesn't. And this is an example of your current presentation. And to be careful what you ask the AI to do. It's just like doing exactly what it was asked to do. It might not be what you had expected it to do, but it did. So this is one of the reasons we need to be very careful with AI ethics, specifically in what we ask an AI to do. So another way that you can do push your computation for the questions. Now this actually is part of the research. So the idea is to take a program, create programs, instruction level, and help to satisfy it. So the selected programming language is very strange. It's terrible. It's very difficult. It's for humans. It's considered a joke program, but it has 3 features perfect use of it. The first set of programming language is a Turing program that is theoretically of solving any computational problem in use. Right? So by extension, AI and itself theoretically, right? Theoretically, that's step 1. Opens the door wide open for what they agree. That was necessary moment. I did want to be restricted in the AI programs. I want to make sure it's perfect. Second is that this program only consists. That's the entire program right there. 1 point each. How is that possible? It is. And it's very well. The simple nature of this program is what so easily. So if this was a more complicated program language, Python, or JavaScript, a lot of instructions or this, it would be much, much more difficult, exponentially difficult. So we only have 8 instructions. It narrows down the potential combinations of programs that are generated and executed in order to create generations and because it's such a small, it's easy to interpret and to say this is important to your life. Problem 100 generations need to execute your program in order to fix with the program language only instructions. It's very fast. Also, if I had to write an interpreter for, say, Java or Python, I write download one if you're and expand upon it too with new instructions. So here's an example of how you create a program. So we start with a random array of values. So remember, we have 100 programs per generation, and we're going to cycle through every epoch. Child numbers and value. When we start random array of values, each floating value comes to one instruction. If we have 8 instructions, we're going to set that range of floating point values across 8 values. What are they going to use? How many sheets? So if we're doing 0.1, if we're doing 0 to 1, 10 values, we're only 2 extra from the instruction. So the 0.1 maps to a 0.6 maps to an increment. 0.7 maps to input on. Now, initially, when we create a random array of this, it's just throwing a bunch of instructions at the wall. Most of these programs will fail. Crash. You can't just take program instructions and slot them into a text file and do this. However, I want programs. One of these is bound to do something. For now, it has the value. Make it equal here. Add a value into memory. It's bound to do something. Let me just minimize this for a second. And it's these programs that will move on to create TAL programs that get better and better over time. So as part of the evolutionary process, crossed over from this portion of parent gene to the child mutation. So in this example, you can see the parent child program, very first second generation of a parent program. The parents contributing these first 5 instructions to the child program. And it's taken the second 5 instructions from another parent program. In addition to crossover, you can also find mutations. Mutation is like radiation hitting. It's like it takes. Here you can see how mutation is right selected in the third to last gene. Changing the floating point value 0.0. That was a random effect, but it has the changing the instruction that's associated with it. Function address shift address. And doing so might make the program worse if it makes the program better. If it makes the program better, that program will that child program will have an advantage over all the others in this generation that will go on to this. If it's worse, it'll help people survival of the fittest and will not continue forward. And so, let's see here. So again, survival of the fittest. We can see here how on the top program has eliminated potential candidates. While the second program uses now, what was the first program? The first instructions. Nothing wrong there. That's fine. Second candidate is terminated. There's a little bit of story that calls this kind of overflow section. And so it's further. The second. And so that's a valid. That's hard program. Full valid is valid. Since it will actually print 2 characters. Console. And so that will have a higher fitness score.
Yeah. I heard feedback from the virtual attendants that they don't have microphones. You couldn't hear you if you walk away from them.
Oh,
Yeah.
okay.
I know. I'm the same way. I always walk around.
Yeah. Should I try to stay over here?
Yeah, great. Thank you very much.
All right. To the Zoom speakers, I'll try and stay over at this location. Hopefully everyone can hear me better from here. So here's some examples of programs that were generated by the AI. You can see how I asked the AI to create a program that could output the word hello. It generated this program. This is a very early version of the AI. This is generated in 29 minutes. And you can see how it did indeed output the word hello, followed by a series of random ASCII codes and garbage, and followed by a Stack Overflow exception. So the operation of the program itself is less important as long as it satisfied the goal. And you can see, since it was asked to output hello, it did write a program that does that successfully. So again, this is another lesson. Be careful what you ask the AI to do, because it just might do it. Even though the program ended up exploding at the end, it still carried out the goal initially. Here's an example. It was asked to write a program that can output the text, "I love all humans." It created this program. It took 10 hours. That's an early version of the AI. A much more recent version of the AI can do this in about 1 minute, perhaps, maybe 2 minutes. You can see the program circled in yellow. That's a valid executing program in the language, and it will indeed print out the text, "I love all humans." Here's a close-up of a program to perform addition. This was done by giving the AI test cases, just like we showed before, of various values and the resulting target. So if you were to actually step through this program, it will indeed perform addition on 2 values. The commas are input values. So we take input for the first gene. The second instruction is a memory upshift command, which will effectively store a variable, followed by another input, which will store the value in the next memory slot, and then it performs addition within the loop. Here's an example of asking the program to calculate the Fibonacci sequence from 2 starting input values. This is generated in 7 hours. This is quite incredible. I can't even read that. I have no idea what that even means. I've been giving this presentation for a couple of years now. I've yet to step through that to try to even understand it. And yet that will indeed calculate the Fibonacci sequence from 2 starting input values and output it to the screen. And that's really quite remarkable that the AI can do this. Now, you will see a couple of different ASCII codes in this program, different from what I showed before from the original 8 instructions. This is an extension of the programming language that I developed specifically for use with evolutionary computation. It includes some extra commands and instructions for doing things that facilitate genetic algorithms, such as it can create functions as part of the program. It can jump forward memory addresses, like go-to statements, and it can fast forward the value in a memory slot as well. So the next type of system I want to talk about is called programming by example. This is made popular by Microsoft in Excel Flashful. This is an incredible feature, and I think it's so important to talk about these things. Everyone wants to talk about ChatGPT, and we will, but these are important too. So programming by example, the user provides input and outputs examples, and the computer has to select a program that matches that input-output example as a solution. So here, the computer is not generating the program. Instead, it's finding it in a huge database of existing programs. Now, you might think, well, gosh, if there's such a huge database of programs, wouldn't that take forever to find one that matches the input-output? Yes, however, programming by example uses logical reasoning and neural guided heuristics. to narrow down the list of candidate programs that match that input and output in order to come up with a target program to give to the user. So this is done by using machine learning. So specifically, the database of programs is collected first. Each program is then, we create a machine learning model from each program. This is done by using a feature set of the programs. So you might take a look at the various features of the program, such as length of the input, length of the output, type of input. Is it a string? Is it an integer? Type of the output, maybe time complexity of the program. How fast does it execute? Memory constraints, things like that can be features of the program. And all of this feature set gets built into that machine learning model. Once we have the model constructed, when the user provides their example of input and output, we again apply the same feature set to the input and output and create a model from that. Then we can search against the machine learning model using different machine learning algorithms such as logistic regression, support vector machines, neural networks, or even clustering in order to find the similarities, to find the programs that match as close as possible to the user's input and output. Those programs get ranked. The ones that are the highest ranked get returned to the user. If there's any disambiguity, or if there's any ambiguity, we can disambiguate the various programs that match too closely in order to select the right one. The way that this is done is through active learning. So we can ask the user, hey, I have two programs that match what you want to do. I'm not sure which one you want, right? Can you provide more input and output examples so I can give you a better score? So the user can give a couple more examples. We can go back, perform it again, and find a program that matches even closer. So that active learning step is very important to help disambiguate. So here's a little graph of how programming by example works. It just kind of dictates what I just described. We have the user examples, right? Input and output. So say the user gives a string such as first and last name. We apply and followed by an output, which maybe is just initials. Maybe we want to convert Kory Becker to KB, right? That's your user example input output. That goes into the search engine. We try to find target programs that match that feature set. So we convert the input output into a feature set. We match it against the database, the machine learning model, and we come up with the program ranker ranks the results. Maybe we take the top 3 results. We have 3 results. That goes into the disambiguator. So are any of those results equal? Do 2 of those programs produce the same input output? Okay, if they do, let's go back to the user, ask for more input output examples, and run the search again. Finally, we take the target solution, return to the user. Maybe it's a regular expression that converts a first last name to just the initials, and that could be the solution. So here's a concrete example. Here's where we want to convert a phone number, a full phone number, into just, what is that? For 7 digits, into a 7-digit phone number. So what we do is the user provides the phone number, they provide the 7-digit phone number, and they're showing exactly what they want done. Better would be to provide multiple phone numbers. This goes into the search engine, right? We construct the feature set from the user's input output, and we search that against the database of programs using the machine learning model that we have. We get the ranking results back, and we take the top result and we return that to the user. Again, if 2 programs are also able to convert that phone number into 7 digits, we ask the user for a couple more examples. Maybe we didn't get the area code right, or maybe we didn't get the international code right, and then we can give that back to the user. So here's an example of program synthesis in the real world, running in Microsoft Excel flash fill. You can try this yourself. It's available in flash fill. It's a really incredible feature. On the left, I have names. I want to reverse the name from last name, first name to be first name, last name. It gets those correct immediately. The second example, we're converting phone numbers into their 7-digit numbers. Notice how it gets a couple of those wrong. So in that case, we're going to use active learning to give another example. By the time we give it the second example, it's able to get all of the rest of them correct. That's an example where 2 programs were picked that had the same fitness score, and we needed to get one of them disambiguated. This is a great example of how active learning can solve that. On to GitHub Copilot. Has anyone used GitHub Copilot? Copilot's incredible. I'm in love with it. I really think it's quite powerful. So GitHub Copilot is an AI-powered program synthesis. It uses context of the code that you're working with. Copilot was acquired by Microsoft as part of its GitHub purchase. This was in 2018, and Microsoft spent $7.5 billion on this acquisition. So at the time, everyone was asking the question saying, what on earth is Microsoft going to do with this, that they're spending $7.5 billion on this? Then later, a year later, Microsoft invested another $1 billion into the research group OpenAI, leading to the release of GitHub Copilot. Is everyone familiar with OpenAI? I hope so, the company. Yeah. So that was very, foretelling for Microsoft and quite smart for them that they did this in 2017, 2018, investing this money into OpenAI, which led to the incredible ChatGPT we'll get to in just a second. But GitHub Copilot alone is very cool. So it works with GPT-3, which is the third generation of the generative pre-trained transformer system. It's built upon Codex, which scans, uses GPT-3 and scans the database of GitHub repos of repositories to build upon the source code with natural language processing and builds a large language model from GitHub code. Let's take a look at what it can do. So it's trained on billions of lines of open source code. We'll get to the good and the bad of that. It's part of Visual Studio Code. Is everyone familiar with Visual Studio Code? Yeah, that's the newer version of Visual Studio. That's very great. So I was playing with GitHub Copilot when it first came out in the beta program, and I recorded some screens. Everyone's probably familiar with what it can do by now, but here's some examples. Can it make a game? I'll let this play through. You can see I have my web browser up on the right side on localhost, and on the left side, I'm typing a comment, and then I just hit the tab key, and GitHub Copilot is able to infer exactly what I want to do and immediately start filling in the code. I tell it, draw a green rectangle. Notice how it's anticipating in the comment what I'm even trying to say, and then it writes the code for it. I just hit tab. There it drew the rectangle in a circle. Now I'm asking it to draw 4 red squares on the bottom. Very precise, separated by a black line. Indeed, it writes that code. Look at that generation. There's the red bar at the bottom with the black border. Isn't this just incredible? It gets even better. Create a bouncing ball. Seriously, right? Create a bouncing ball. Look how it's creating the coordinates to store the object, ball.draw. Okay, now I'm saying move the ball, right? I don't even tell it how, just move the ball. Here it goes, creating an interval. Look at that. I mean, come on now. I was just blown away when GitHub Copilot did this. And this is real time. That took about, 30 seconds? It's remarkable, truly remarkable. Can it make a form submit? Here we're getting some more useful applications. Take a look at this playing. Again, I'm writing the comment. Notice how it said display a list of books, right? That's pretty close too, but I'm like, no, display a form, let the user type in their names, right? I want to show an HTML form. I want to let the user type in their name. When they do it, I want to have it added to a list that displays on the page. So notice here how I'm kind of guiding GitHub Copilot into what I want done, but then it's able to fill in all of that code. Look at that. It filled in the render method almost perfectly. I just adjusted slightly. Here, this is a React component. It's creating a React component for me. I'm asking it to use state. It comes up with state. Here it goes, setting the values to store that state, the state variable information. And I try to run it, but we're not rendering anything yet. So what are we missing? We're missing the, there it is, the react.render commands. So it added that. So nothing's still displaying. What are we missing? Let's see here. Okay, so here it's creating the event handlers. Okay, now it's rendering the text box and the button. So there's only a little bit left of this. We'll just let it finish up. So the interesting thing here is that I included an HTML comment in order to have it to prompt it for the type of output. And you can see here, once I did that, it was able to correctly render those names. All right, so the good of Copilot, it's advanced program synthesis that we've seen. It makes it very easy to quote, get answers from Stack Overflow and instantly have that added to your code. So this really does speed up development time. I found that for myself, at least, you can almost start to lean on it like a crutch, which might be some of the downsides. So as great as it is, there are some downsides with it. One of them is slow code completion and interruption. So GitHub Copilot can tend to be interrupted. It kind of jumps itself in, showing those comments when maybe that's not what you were looking for. There could be lag time over the internet, where if you're, as you're typing, you're waiting for an answer, but you get that network latency to get an answer back. It could provide broken code suggestions. So code isn't perfect. It's scanning GitHub repos. Some of the code is good, some of the code is bad. It usually gives you good code suggestions, but not all the time. So you do still need to use due diligence in the code that it suggests for you, which leads us to developer dependency. When you're using Copilot, it's very easy to slip into a mindset of letting the computer do it all for you, and you get lazy. And this is something that we might be seeing going forward with AI, especially with the large language models, where it's doing more and more for us. So why should we bother doing work, right? But maybe that's just the evolution of humans. Maybe that's a good thing. We'll talk about that in a second too. With developer dependency, there's two specific types. There's anchoring bias and automation bias. Automation bias is when humans tend to value an automated result over a manual result. This happens in healthcare. When you walk into a doctor's office, they run your symptoms through a program and it automatically comes up with a diagnosis. You have a cold, you have the flu. However, a very experienced doctor might be able to pick up on something outside of that automation, such as the tone of their skin, or maybe the way that they walked in the room, or maybe something that they've said that they have for breakfast. And it's those little subtle clues that might lead the doctor to think, no, this is not just a cold, this is something more serious. So that's an example where automation bias is important to be aware of. Second is anchoring bias. Anchoring bias is where a developer may be too fixated on the first result and cannot think out of the box into different ideas. So when GitHub Copilot suggests a solution, the developer might be fixated on that one particular solution instead of thinking about other ideas out of the box that could also solve that problem. And that can be an issue. And of course, there's copyright concerns. Since GitHub Copilot is scanning open source repositories, it's possible to, quote, launder open source code out of its license, MIT, Apache, what have you, and into public open source, into a different type of license when that's not what it was intended. It could even be picking up on copyrighted content from GitHub repos and laundering that into open source, which it was not intended to do. So those are some issues. And that brings us forward into the latest and greatest large language model, which is ChatGPT. So ChatGPT, is everyone familiar with ChatGPT? If you had a chance to try it? Yeah, probably most of us. So of course, you know, it can answer a range of topics. It's the closest I've ever seen in the history of computing myself to an AGI, which is artificial general intelligence. Whether it is or whether it is not, that will remain to be seen. Right now, let's just say it is certainly not, but it's incredibly powerful. It can write programs for you, just like Copilot. It can create a quiz for you based on the seasons of the year. It can write an article that's never, a story that's never been created before about your favorite TV show. It's quite amazing. It can tell you how to cook eggs in the morning. I've always said, I will be impressed when there's an AI that can write code for me, that can write a story and can cook me eggs in the morning. And ChatGPT can do all of those things. It's a fine-tuned model from GPT 3.5. And now we're up to GPT-4, of course, or ChatGPT 4. So 3.5 is a conversational version, fine-tuned version for conversational UI of the GPT-3 series. It uses, so ChatGPT uses a form of program synthesis from reinforcement learning from human feedback. And I'm going to show you how this works, which is how ChatGPT works. It's actually quite interesting. So ChatGPT uses a 3-step training process in order to work. The first 2 steps are human. The 3rd step is completely automated. Now, keep in mind that ChatGPT also forms a large language model from word associations, has nothing to do with human context. This is for fine-tuning. And they've even explained as part of ChatGPT 4, they're using less human interaction. But let me just talk about this anyway, because ChatGPT 4 is so new. I didn't even have time to adjust the slides for that. That's how fast things are moving. So the first step, it's supervised training. A prompt is selected from the database, and different humans are asked for the answer to that prompt. The second stage is also human. In this one, a prompt is selected from the database, and multiple answers are given from humans that gave them before, and a human has to rank those answers from best to worst. And the last step is completely automated reinforcement learning. So as we go through each one, the first step, a prompt is randomly selected from the database, and a human is asked, what's the answer to this? What's the correct answer? So, for example, we might say, describe the national parks in the United States. And the human might say, okay, Yellowstone, Shenandoah. A second human might say, Yosemite. A third human might say, Las Vegas, New York, Florida. A fourth human might say, gas combustible engines. That has nothing to do with it. I don't know why somebody might say that, but this is what can end up in the database. That's how the first step works. The second step is training the reward model, ChatGPT. A prompt is randomly selected from the database, and with several answers that were provided, and the human has to rank them. So going by the last example, describe the national parks in the United States. So the examples that are provided to the human might say, number 1, Yellowstone, Shenandoah, Yosemite. Okay, that's pretty good. I'm going to rank that number 1, right? Those are all national parks. The second answer was combustible engines powered by gasoline. That has nothing to do with national parks. I'm going to rank that number 4, lowest rank. Maybe another human said Great Barrier Reef, Great Wall of China. Well, those aren't national, national parks, but they're like sort of, important, prominent figures in the world. So I'll rank that like 2 or 3. If ChatGPT gave that as a response to this question, it's understandable, but it's not great. Maybe another one was Florida, California, Nevada, right? That'll be ranked. That's not national parks, but those are states that contain national parks, not Florida. I'm not sure. Maybe it does. So that would be ranked maybe 2 or something. Finally, a completely automated reinforcement learning is the last step of the process. And this calculates the output reward and updates the policy. This is using an algorithm called proximal policy optimization. You can look up the details of how that algorithm works, but it minimizes loss while maximizing the gain for coming up with the correct result. And this is how ChatGPT works. So let's see what it can do. I asked it to create a program, classic, to output the Fibonacci sequence, right? So here you can see it had no trouble at all. It came up with the result of this program in a split second. It's using recursion. It looks perfect to me, except that it's using recursion. I would have preferred an iterative approach, and it could indeed do that if you asked it to. But I took this code, plugged it into Replit. If you haven't used Replit.com before, I highly recommend it. It's a wonderful online IDE. It can do different programming languages. It's great. You can see Replit on the right side there. I executed that code. Indeed, 011235. That is the Fibonacci sequence. So I asked it to create a web page with a contact form. It had no trouble doing this either, just like GitHub Copilot. You can see it even centered the the fields for the form in the middle of the page. I didn't even ask it to do that. It creates CSS to do that. I pasted this into CodePen just to prove it, codepen.io, another great online site for mocking of web pages and running them, just like JS Fiddle. The form looks fantastic. I then asked it, okay, great. Now, when I submit that form, can you email me the results? And it told me, yes, you can do that with a Perl script, a CGI script, or a Python script. So I said, well, I don't want to do a server-side program just to get the form submission. Can you do this in another way? And it said, yes, you can use a service such as FormsFree or Google Forms. So I said, okay, are any of those free and don't require an API key? And it said, yes, FormsFree is free and does not require an API key. So then it went on to show me how I could do that and submit this form. I couldn't include all that in that slide, but it indeed worked. And the coup de grace, I asked it to invent a programming language based on Dungeons and Dragons, the game. It came up with this incredible programming language. It even suggested a name for it. It suggested Dungeon Magic, which references the magic-based elements of the language and inspiration from D&D. And it also gave an alternative of Dungeon Cast, referring to the cast method it came up with, which is the print statement. I went with Dungeon Cast because I thought that was perfect. And it's really quite remarkable. I'm a little bit short on time. I want to leave time for Q&A, but I'm happy to talk about all the details that it suggested to me as part of this programming language afterwards, if you're curious. Things such as it came up with ideas as integers could be represented by a D6, a string could be represented by a D10, a Boolean could be a D2, makes complete sense. Control structures could be different types of monsters. A loop could be a dragon that attacks until a condition is met. An if statement could be a Medusa that turns people to stone if they meet a certain condition. These icons at the bottom and the right were generated by Stable Diffusion, another large language model, which is also quite incredible. I asked it to create icon images to represent this programming language, and this is what it came up with. I'm particularly impressed by the bottom two on the right. I think that pink one looks incredible. It even has text that almost looks like the word dungeon. And the one at the bottom middle almost looks like a tile set, which refers to programming instructions in the language. I think those are fantastic. You can try Stable Diffusion on stablediffusionweb.com. It's free. You can type in anything and it will generate images that have never been seen before. It's really quite amazing. What are the limitations of ChatGPT? Well, the outputs that it can give can be plausible but incorrect. Why? Because there's no single source value of truth. It's coming from humans. Humans can make mistakes. Just as we saw, the first two training steps were human-based. That's where these plausible but incorrect outputs are coming from. Also from incorrect connections, but also from humans. This goes on to sensitive to phrasing conversations. You could say the same thing and get two different outputs. This is just because of the stochastic nature of how large language models operate. There's some randomness in those outputs. Another problem, the ChatGPT can guess the intent of the user instead of clarifying what the intention is. This goes back to programming by example. Remember when we used active learning to disambiguate programs that are the same? ChatGPT doesn't do that. If it did, that could be a lot better. So imagine if you ask ChatGPT to do something and it comes back and said, well, are you sure you want that or do you want this? I'm not really sure. It doesn't do that because it wants to just give the best answer as fast as it can. And that's one of the problems. There's also content bias, false negatives, and things like material that's considered harmful or even related to healthcare that ChatGPT might block talking about because it deems it harmful. And that's unfortunate. That's a false negative. The other thing is that ChatGPT has no rudimentary knowledge of what mathematics is, although it seems to be able to calculate math on its own, which is quite incredible. Things such as addition, subtraction, it doesn't know how to do that or take that into account, less than or greater. However, even though it doesn't know how to carry the one to perform addition, the basics of mathematics, it's able to figure out how to do that through the large language model itself. It figures out how to carry the one It figures out how to do addition with multiple digits. And it's quite incredible how a large language model is able to do this, which makes you start to question, perhaps the human brain doesn't know how to do math either. And all we're doing is forming associations to carry the one to perform mathematics as well. ChatGPT has no notion of time. And also it's using outdated training from 2021 or 2020 rather than 2023. But these are bound to get better and improve, as we're seeing with ChatGPT 4, which is already incredible high scores on the GRE, the SAT, the bar exam. It's really amazing the scores. And over ChatGPT 3, version 4 is significantly higher with all these test scores. And that's in beta right now. So I want to leave this presentation off in this conclusion with a quote that was in the ACM January newsletter of this year, an article by Matt Welsh titled The End of Programming. And Matt Welsh said, a fundamental change in how computer science will be taught is occurring. We're not just talking about GitHub Copilot replacing programmers, but rather we're talking about replacing the entire concept of writing computer software with training models. Just as in the 1960s, engineers needed to know how a transistor works and a capacitor works, and in the 1980s and onward, developers didn't need to know about transistors anymore, or capacitors, or how a computer works. They could just write software. Today's developers probably don't even know how a transistor works or even what one is, but they might know what a stack or a linked list is. The future of software developers may not need to know any of this, or even how to write code, or even what programming code is at all. All you'll need to know how to do is to ask a computer to do it for you. So we might need to change the entire concept of computer science into a whole new world. And with that, that's the end of the presentation. If you enjoyed this, check out my website. I have articles about this. My research work is right there at that link. Follow me on LinkedIn and on Twitter. I'm also on medium.com. You can follow me there as well. And if we have a couple minutes, I'll take a couple questions. Yeah, go ahead.
This is best suited to things that have been done before. So not useful. Achieve doesn't invent doing a search for things that exist, maybe putting certain things together, maybe talk about limitations of this putting together process that things that it can't do.
Sure. Thank you for that question. That's a great question. So the question is, can evolutionary AI, can program synthesis like ChatGPT, should we focus on ChatGPT for now or just in general? Can a system like that invent something new is the question. And I do believe that the answer to that is a resounding yes, it can. So you are correct that it's using existing information from the knowledge of humanity, right, in order to come up with new inventions. How is it able to do this? So there's some science fiction books that talk about entire areas of science that deal exclusively with leveraging existing human knowledge to create new knowledge. But you might think all you're doing is regurgitating existing things. However, that is how inventions can occur. It doesn't always have to be a completely new, out of the universe thing that happens. An asteroid crashes into the Earth with a brand new mineral we've never seen ever before. Instead, it could be from gene sequencing, perhaps with quantum computing, which is research that I do, that's discovered a new arrangement of molecules that have never been tried before by humanity, but that exist in our knowledge base. And that sequence of molecules creates a whole new element that happens to cure cancer. So that's an example of a new invention. ChatGPT can also come up with new knowledge to invent things. So I read an article just yesterday where ChatGPT invented a new programming language. Now you might say, well, Dungeon Cast, that was a new programming language. This blew my mind away. It created a new programming language based upon ChatGPT itself. This is just so meta. It actually, the language itself, I've never seen anything like this. It came up the ability to perform refactoring in line in the programming language and offer descriptions and code suggestions of the code as you're writing it, built into the programming language. It almost made no sense to me. It's almost like GitHub Copilot, which is after the fact as you're typing, but in the code itself. You'd have to read the article. I don't even fully understand it, but that's an example of inventing something completely. Yeah.
Yeah, I think your comments now about the invention process. I spend a lot of time on patents, patent research, and I'm my consultant. It's a lot of innovative thinking, and there's complete methodology. This when we talk about supervised learning, would be interesting to see if you give it, for example, the TRIZ methodology, the innovative patents. It's a Russian methodology on how to come up with invention, and it's pretty cool. But there's techniques. There's other tools that use databases, existing patents, global patent databases to come up with invention. And it's a company, Innovation IQ, that ITPC was that I had used. I use it in my consulting. But to me, is this a limitation of the supervised, the actual content, supervised learning? In other words, if I give them more examples of the invention process, do I have control of that part? Check.
So I guess the question is, can you extend ChatGPT by giving it more examples on a particular topic? Yes, you can. They're still working on it. There's, a limited amount of characters that you can provide as a prompt. But you can feed ChatGPT new information to have it learn from that. I can't comment too much. I'm not so familiar on the patent process or invention process, but what you're describing sounds very interesting.
Also
yeah.
comment about math. It's my understanding of basic math has separate and supervised learn from the math grades, right? Like 20% of what I teach here is Fourier and lots of transfer. So teach them the fundamentals of how that process, when you hasn't been taught in grade math.
I'm not sure the answer to that question. I think I want to say yes and no. It's ingested information from math experts through textbooks and human knowledge on the internet. So I want to say probably yes is the answer to that. Far more knowledge about math than any one of us in this room, even collectively combined, could ever ascertain. Does it truly understand mathematics? That's a question. But then you could also say, do humans truly understand mathematics either? So, one of the things I was thinking about more recently on a tangent to that question and that topic is, and thank you for asking that, by the way, is, what does it even mean to be human and conscious? And people think that, oh, we're talking to ChatGPT, it's just like a mirror, and we're acting like it's a conscious being, but it's just a robot, and it's just forming patterns from things it's already seen. But maybe if you reverse it, maybe that's the same thing we are, and then we're not so different because of what we're seeing ChatGPT do just from the 175 billion connections that it's created. Is it possible in some of those connections that it's managed to generalize consciousness as part of that network? That's what we don't know, and that's quite possible. We'll see what happens when we get ChatGPT 5 and 10 and 100. There might be a certain number where perhaps we get further. Yes.
Right. So it's a question of supervised learning. It's by cases. Maybe like on cases.
Yeah.
I have a good question for you.
Sure.
Next speaker, ready? The best That's why you made mathematics, right? You said some application. Okay, can you elaborate?
Sure. So the question is, can we elaborate on the mathematical limitations of ChatGPT?
ChatGPT noise.
That's great.
That's great. That's the application. But I think I'm just talking about this thing. Okay.
Oh, yeah, sure, sure.
I guess a general question for you is that since you're the expert in ChatGPT, how do you feel? Do you feel personally this is something that you can use for your job, or you can use the personal thing, or do you like, or that's my thing.
Okay, let's finish with that question. This will be the last question. Thank you for asking that. That's a fantastic closing question. Oh, we have to talk then. We have to talk, please do.
I give you a simple. I teach now 25 years. Yeah, I went to ChatGPT, like 25 and I was out for 25 years. I went to ChatGPT. I said, give me the street bicycle. ChatGPT give me street bicycle. 3 books I will never use. After 25 years, right, I read about all these different books right now. And they give me something that I never understand. What would that? Another thing is, whenever you send something to ChatGPT, they don't give you a big answer. They give you 300 answer. I don't need that. Okay, you may want that, but I don't. You're a writer, right? Being a writer, that's great. Which give you a lot of things to think. That's a big answer. But to me, I'm an engineer. I'm a professor. I have big answer. I don't want 300 answer. But that's why I don't like ChatGPT. It's just not finding.
You also want how to explain the bias.
Yeah, exactly.
Which they are.
It's basically like to me,
Why do you
ChatGPT has too much answer.
Michael,
Which I wouldn't give. It's always you got time, you got real. Anyway, so do you like it?
well, you clearly strong.
Okay.
I think it's pretty good. Let's see what I can do. Let's see.
Yes.
Thank you very much, everyone.
Well, yeah, so Bill Walker is wrapping up over in his so speakers are waiting in 1:54 to get started. So if anybody wants to visit that as well. Okay, Stephen Leonard's here. Okay, that's good. I don't know. Tonight might be a